So this video is going to talk about some questions that could come up just talking about graphs and using key features to write equations based on those graphs. So the first type of question that we might come across is one that we're asked to find the roots or the vertex, and we're going to be able to use technology for that. So I already have this in Desmos, and I'm going to switch over to Desmos. So you'll see I have my equation in here. I can't see everything I want to see just yet. So I'm going to use my mouse cursor and I'm going to scroll out until I can see everything that I want. They want the vertex and they want the roots. So that means that I need to find this point right here. And if I click on my graph, you'll notice that the roots, the y-intercept, and the vertex have all come up. So the vertex would be 549. And I'm also going to note, just because it is possible that they might ask us, that is a maximum. And then I have two roots. So I would say that the roots, oops, if I could spell, the roots are x equals -2 and x equals 12. It is also possible that they might ask you for the coordinates. And if that's the case, then this is exactly what I would put in. I would put in -2, 0 and 12, 0 for the value of the roots. So that's how I would find these answers for question number 1. But the more important thing that we need to look at today is if we come across questions like this, how we're going to go about writing that. Now, factored form is exactly what it sounds like. It's the form of the equation that shows us the factors. And I'm going to work backwards from the roots to find the factors. So I have this point here and that point there. So this tells me that x equals -3 and x equals 5. And those are my two roots. Now, when I found the roots, I took the factors, set them equal to 0, and found x by itself. So now I need to work backwards, and I need to get a statement with x and its root that turn it into being equal to 0. So what I'm going to actually do is make this side of the equation turn out to be 0. So I'm going to add 3 to both sides. So the factor that I started with was x plus 3, and that's what was equal to 0. And I'm going to do the same thing over here. I'm going to subtract 5 from both sides. So I'll have x minus 5 equals 0. So my two factors are x plus 3 times x minus 5. And I'm going to use another point to test if this works or not for my equation. And I'm going to use the vertex because that is a perfect point that's on tick marks. I could have also used -1, 6. I could have used that point there. I could have also used 3, 6. If the y-intercept had been on a tick mark, I could have used that as well. So I'm going to test the point 1, 8. In my equation. So this is going to be x and this is going to be y. So I'm going to substitute these numbers into this equation up here. So I want to know if 8 ends up being equal to 1 plus 3 times 1 minus 5. And if it's true, then I know this equation is correct. So 1 plus 3 gives me 4. 1 minus 5 gives me negative 4. So I have 4 times negative 4, which gives me negative 16. But that's not what I had for a y value. This y value, I know, is correct. I have to manipulate this negative 16 to now make it equal to 8. This tells me, the fact that these are not equal tells me that I am missing the greatest common factor that was out here in the front. So what do I have to do to negative 16 to make it equal to positive 8? Well, I have to multiply it by negative 1, and I also have to multiply it by 1/2. So I'm going to multiply this by negative 1/2, and that will get me 8. So that tells me that my equation is negative. Now you could put 0.5 or 1/2. You know that I don't love decimals, so I'm going to do 1/2. And then my factors, x minus 5. And this is the factored form of this graph that I was given. And this coefficient here is what would be in front of x squared if I was looking at it in standard form. The fact that this coefficient is negative tells me my graph would be upside down, which it is, and it has a factor of 1/2, which tells me this graph would be wider than if it was just negative x plus 3 times x minus 5. So this is what it looks like in factored form. There are possibilities that they could also ask you for this in standard form. The process isn't going to be any different. I'm going to still write it in factored form first, and then I'm going to use the box method with multiplication to find the standard form. Now, when you're given questions like this on a test or a quiz or practice, it is very likely that you will have multiple choice answers. But what I'm showing you is a way to double check that the answers that are given, that you agree with one of them. So here is my root. My root is x equals negative 3. To find my factor from my root, I'm going to set this equal to 0. So this tells me x plus 3 equals 0. Now there's only one root, which means that this factor is being squared. So I'm going to find a point to test to see if this is correct. Now I'm going to test the y-intercept because it happens to be a perfect point that I can use that's on tick marks. I could have also used negative 6, positive 3. That would have been okay. So my test point is going to be 0, 3. So this is my x value and this is my y value. So I'm going to go ahead and substitute those in. So 0 plus 3 gives me 3. 3 squared gives me 9. 9 is not equal to 3. Now I know this has to stay as it is. So I have to tweak 9 to create 3. Well, in order to do that, I have to multiply by 1/3. So 1/3 becomes my coefficient in front of this factor. So I'll have y equals 1/3 times x plus 3 squared. Now this would be my factored form. because it's showing me my factors. And in Math 2, you'll find another thing out about this particular form. This is one of those special cases that we talked about in factoring. But for our intents and purposes in Math 1, we're just going to look at this as this is giving me my factored root. They didn't want factored form, though. They want standard form. So the first thing that I need to deal with is this x plus 3 squared. Now I don't have enough room, so I'm going to grab another piece of paper. So I have x plus 3 squared that I'm going to deal with first. This tells me that I have to do x plus 3 times x plus 3. So we're going to go to the box. I have x plus 3 times x plus 3. So this is x squared, 3x, 3x, and 9. So inside of the box has become x squared plus 6x plus 9. However, I am missing this 1/3. So I need to multiply this whole thing by 1/3. And now I will get my standard form. So 1/3 times x squared just gives me 1/3 x squared. 1/3 times 6x, well, 1/3 of 6 is 2. And then 1/3 of 9 is 3. So this is my standard form that matches with this graph from above. So these two forms, you can't see that, can you? This factored form and this standard form are equivalent equations that both represent this graph. What I can see from factored form are my roots. I can see x plus 3 equals 0, so x has to be -3. From standard form, I can very quickly see my y-intercept, so that's where this 3 comes. And I can look at this coefficient and see it's positive, so it should open up. So those are things that are highlighted in factored form and in vertex form.